So today we're going to be working on, starting Unit 4. So again, we're just kind of talking more about triangles. Last unit we talked about how to prove they were congruent. And now we're going to be looking at special parts of the triangles, both within and without. Okay, so for today, we're just going to take a look specifically at the special segments that are involved in the triangles for Unit 4. Okay, so our first one we have is a perpendicular bisector. We've heard that before in previous units, but today we're going to be diving a little bit deeper into it. Not much though. Okay, so remember a bisector from Unit 1 is a either line, ray, segment, or it can sometimes be a plane. Okay, a bisector is just one of these four things that cuts something else in half. Okay, so it bisects, cuts into two equal parts. Okay, so a perpendicular bisector is a bisector that is also going to be perpendicular. Right? Remember, perpendicular makes that 90-degree angle. So if we're looking at our example right here, we're told line RS, so this line right here, is a perpendicular bisector to, of JK. So JK is our segment, okay, and then RS, we can see, is cutting it in that 90-degree perpendicular way, okay, and then if we're looking at JK, we have these marks of congruency, so we can say that JR is congruent to RK, okay, and again, the reason is it's being cut by that perpendicular bisector, so this half will be equal to this half. Okay, so as far as a perpendicular bisector goes, so in triangles, it's not always going to be through the vertex. So sometimes you guys might see a perpendicular bisector that looks like this. Okay, and it goes through that point right there. But keep in mind, it's not always going to go through the vertex. Okay, over here is our bisector. The thing you want to remember about bisectors is it has to cut the base into two equal parts. Okay, so if our bisector was over here, our base wouldn't be congruent, right? So keep that in mind, but just remember it always has to have that 90-degree angle for it to be perpendicular. Okay, so moving on to an angle bisector. So again, we've talked about bisectors before in Unit 1. So an angle bisector is again a bisector that divides an angle, okay, into two congruent angles. Okay, so if we have angle ABC here, ABC, right, and we're told that BD, this ray, is the bisector. Remember, bisector cuts into two equal parts, so this half is equal to this half. Right? We could say angle ABD. So ABD, this part of the angle, is going to be congruent to angle DBC. Okay? And again, that's because it's being cut by this angle bisector. Right? It's cut in half. Okay, so before we move on, I want to emphasize kind of the vocabulary of this. So we're going to work on vocabulary this unit as we're going, instead of just visiting all of it at the beginning. So perpendicular bisector is going to be up here in our vocabulary slide. And remember, we determined that to be a bisector that is perpendicular. Right, remember in the symbol for perpendicular is that to a segment. Okay, and if we were to draw an example, say we could say JK. We'll say that our bisector is right here, LM. Okay, and then we know that because LM is a perpendicular bisector of JK. All right. And then for the next one we have is an angle bisector. So that is, again, a bisector. That divides an angle into two congruent angles. Okay, and if we were to do an example, so I would have, let's say, LMO, okay, and then our angle bisector we could say is JK, okay, so JK is an angle bisector of angle LMO. Alrighty, so we have two more. Okay, so moving back down to our notes, we have altitude and median. Okay, so altitude is going to be a segment from a vertex to the line containing both the opposite side and is perpendicular to the line containing that side. What? So let's break it down. A segment, okay, so an altitude is going to be a segment, right, from a vertex to the line. So vertex, remember, is the point of a triangle, to a line containing the opposite side and is also perpendicular to the line containing that side. So what it looks like in a picture, we're told we have triangle A, B, C. Okay, so A, B, C right here. BD, this red, in this case it'll be pink, this is going to be the altitude from B to AC. Right? The reason it is an altitude, we are starting at the vertex. So remember, vertex is a point of a triangle. Okay, and it is going to the opposite side. Okay, so here we have side AC, which is opposite, and it is also perpendicular. So the altitude you can kind of think of maybe like a word to remember as height. Okay, so the altitude would be basically the height of your triangle. So from a vertex to the opposite side, right? But remember, it has to be perpendicular. Okay, so in another example we might see here, if we have triangle ABC, we see it's kind of slanted more so. Sometimes our altitude has to be written outside of our triangle. Okay, so BD again is the altitude, but you see here we had to draw this auxiliary line to get the actual height of that triangle. Okay, all right, and again, it starts at a vertex, it goes to the opposite side, and is perpendicular to the opposite side. Okay, so that is altitude. We can go ahead and put that in our vocabulary. Right, altitude is right here. So we say that's a segment from the vertex to an opposite side. All right, and it's perpendicular to that side. Okay? So for a picture example, if we have triangle ABC, so ABC, our altitude, we could say, starts at B, comes down here. If BD is the altitude, all right, we start at that vertex, we are a segment going to the opposite side, and we are perpendicular. Okay. And then last special segment that we have is going to be a median. Right? When you think of the word median, what do you think? So I tend to think of middle. Okay. So the median might have to do something with the middle, you know, like if you're driving on the road and they're like, stay out of the median, right? That's the middle of your two streets, right? Okay, so a median is going to be a segment with endpoints being the vertex of the triangle and the midpoint of the opposite side. All right, so it sounds very familiar to an altitude, but, okay, CD, all right, is our median. So again, we started a vertex, we go to the opposite side, but the key thing here with the median, it's going to be the midpoint, okay, midpoint, very important. Remember, a midpoint creates two congruent parts. So we could say AD is congruent to DB, right? The biggest difference between altitude and median, all right? Make notes of this. Perpendicular, okay? So, as we see over here, we don't necessarily have congruency created by an altitude, but the median is going to create two congruent parts, as we can see labeled here, because it goes to the midpoint or the middle of that segment. Okay, so we'll fill in our vocabulary again, right? The median is a segment that begins at the vertex and ends at the midpoint of the opposite side. Okay, so for a picture example, we have a triangle. We'll do ABC again. Okay, if BD is our median, okay, we know we're going to start at that vertex. We're going to go to our opposite side. All right, so we'll say like right here, BD. And then remember, key term for median, we have two congruent parts on that side. Okay, so good work today, guys. Go ahead and start on your assignment. Let me know if you have any questions. Bye.